Okay, now I'm recording again. Sorry about this delay, but that's seemed that there was another guy coming in and something went wrong with his email address for some reason. But anyway, we've set up a Navipack with a vessel and two instruments, a surface navigation and a gyro instrument. And let's try to save the project. File, save as. Navipack will always default to this location, C Ivan Navipack DB. But I have given you guys a location on the C drive, virtual training on or off 2021. Project. I'm fully aware, Stephen, that you might not have it because I don't know if you didn't receive the mail or whatever. Oh, you have it. That's good to hear. Anyway, NP configurations. Yeah. This is where I suggest that we place it, and we will call this one virtual on. Like this, virtual on off. Project file, NPP. This is an XML file, and the extension is, of course, short for Navipack project. If we look at the project folder, this is just my suggestion to a project folder. There are no Navipack default structure here. It's up to you to make one, but this is a good choice. I think you can actually see here that I got these headlines underneath the project main folder, and it's, well, basically taking more or less everything into account. This is a little bit special because this also has offline stuff like Naviedit and Navimodel, Naviplot for that matter. But I'll place it inside np_configurations here and save it. In the caption, now you see that it's called virtual_on_off as expected, and also see that there is something called recent. It's here in the recent list. The first one in the recent list, of course, is not relevant because that's basically the current configuration, which will be opened automatically, but it gives us an idea about the location of it and the actual name. Now, if we look at the tree to the left here, you can see there's something called project settings. So if you click on that once, then this dialog will pop up. There's quite a lot of items here. One of these items or headlines, you could call them tabs, is the one that's called Navipack. And here you can see the navigation cycle, possibilities, time, 1 second. This is the default. You can also change it to input. That means that it will then be related to an incoming data string. That could be, for instance, the GPS. That means that our navigation cycle will start whenever we receive data from the GPS, for instance. Some people like that. Absolute time is a little bit like time, but here we will have it on the integer second rather than on a random, on arbitrary decimal second. Cycle period, it doesn't mean that we're not logging all data. It just means that the navigation cycle part of what Navipack is doing is conducted once every second. That, for instance, means that the HelpSense display will be updated once every second, but data will be logged with the time tagging that they have, irrespective of the cycle period. So that should not be the reason why you want to do that. Coming back to Kuram's question, the value is not given by the manufacturer because you can define different settings. You can define on your instrument output rate, etc. Typically, there's a limitation to the output rate that could be related to the baud rate. Of course, the lower baud rate, the lower output rate you can have, because there's simply not enough time to output data when you doing if you're doing it with a low baud rate, that is a low speed. So if you want a high baud rate or want a high output rate, then high output rate as well. How high baud rate, then you get a possibility of a high output rate, but it's not manufacturer specified at all. Now, there's so many things here, and I trust that you guys have done the e-learning, so I'm not going to go into too much detail about it. What I want to do is to go to Warm Start, the Warm Start tab. This is where we are given the possibility to tell Navipack which programs, help programs or sub-programs are we going to start when we enter online mode. Online is always there by default, and that's a good idea because online is like the gateway to other programs. I always keep that open as well, but I would suggest that we also open the HelpSense display. We might as well do that because we'll be looking at it all the time anyway. So let's enable HelpSense display and say okay to these settings. We will come back to the project settings many times during the training, so don't worry that you don't understand everything by now. We're now ready to go online. We do that from one of these three up here. We can reset and start. Let me just show you what it's really about. I think I closed that PowerPoint presentation. Coming now. This is the one we were using this morning. I got a slide I want to show you. This one here, we've been configuring, and now we want to go online. When we enter online mode, Navipack will create a database file, gensetup.db, which is equivalent to our NPP file, but it can be used online. At the same time, Navipack will keep what is known as an online DB. This contains information about the configuration online, the settings online, which instrument that we have chosen, because we could have several surface navigation instruments, but we are not necessarily using all of them online. But Navipack will compare these two and say, are they in compliance? If they are in compliance, you can do an automatic start. That basically means that you don't have to select instruments or anything like that. You just press the button once and then you enter online mode. If they are not in compliance, and they won't be in compliance, for instance, if you have added a new instrument to your configuration, you are forced to do a manual start. You can also, because Navipack will show you whether they are in compliance or not, you can reset here. That means that you force a manual start. And I always do that during mobilization, which is basically what we're doing right now. So I will reset, and then I will press start. This will be a manual start then, which we can see by the fact that we are prompted using this dialog to define which surface navigation instruments to use. This is the available list, also underwater navigation or remote navigation. Well, we haven't defined any. This is the available list. This is the selected list. So we move instruments from available to selected by highlighting the instrument in the available list and pressing the arrow right. So now I will say OK to that. And OK. Always say OK to the proposed position. This is just something that Navipec is using to calculate or to initiate the Kalman calculation it's using to calculate course made good, speed made good, etc. Don't worry about this one. This is my Helsense display. It remembers it from the last time. What you should worry about is this one here. This is your simulator. Because basically we have one instrument in simulated mode, then the simulator will always pop up. Now, let's go to the Helsense display, which is looking totally different from yours, but mine will look the same if I say File, Save Project As, and you should basically do the same. File, Save Project As, and then you go to Browse here, and then you find the location. Virtual training on off 2021. The project, Helsense. You select this folder, and then you give your project a name. I don't have that much imagination. I'll just give it the same name as I've done already 3 times by now, the vessel, Navipec project, and now also the Helsense display project. The extension is HMP, as you can see here, Helmsman project. It is also an XML file. So I'll say save to that. I think I did it in the wrong sequence. I should have said new first. Never mind that. Sorry about that. Should have said new first and then said file, save project as. Now at least it's available in the list. So now Konstantin is here. Welcome, Konstantin. Took a little while. I think that was my fault. I think if I were you, Konstantin, I would just lean back and look at what we're doing. And then the exercise of the afternoon will be to make this configuration anyway. So you won't be missing too much. Only the initial talk here. Anyway, I've recorded this session, so you can always have the recording if you want to. But anyway, I'm choosing the location from the drop-down, which is now including the location I chose before here. And then I give it the same name as I did before. And here it is. We are communicating via the chat, but I can see you've already seen that, so that's fine. The headset display here is a program that is or can be linked to NaviPack. If you look at the icon, the yellow L up here, L stands for line planning. So basically, we are in offline mode, you could call it also. It's not linked to NaviPack. To link to NaviPack, you must press the icon to the left of the yellow L. And now, as you can see, I got the 3 computers on my network here. And the one I want to use is the one that has the local IP address 127.0.0.1, and it's called NaviPack kernel. That's the only one we have at the moment. But this is the one you should choose. Highlight it and press connect. 2 things happen. Instead of the yellow M, I have a green M, and green stands for master. So I'm the master. So that basically means I'm connected to NaviPack on this computer. The second thing that happened is that there's now something called NaviPack connection. If I explode it, then you can see I got the vehicles underneath. And I have my vehicle called virtual on-off. It's here somewhere, and it's actually here in the map view, as you can see. If you right-click in the project tree and choose attach 3D model, then you can choose the tug. I always do that. I don't take the tankers. People are really inclined to choose the tankers, but that's really difficult to have an RV underneath a tanker without losing eyesight of it. So I will choose the tug here. There you go. There it is. There is the tug. The filtered vessel. I don't want to see that. I don't need to see it because it's basically just something NaviPack is creating by default. But here it is in 3D. And if I take my simulator and I start sailing, and you can see that it also starts moving. And I can also change the heading of it like this. NaviPack has a functionality whereby you can sail on a run line, and that of course is only in simulation mode. Let's try to do that. But first, before we do it, let's see how we can load a run line into the headset display. The easiest way to do it, and basically also the only correct way to do it, is to use Windows Explorer. I'll go to C drive, IVA, Yeah, I can see ELB26. My Helsense display failed to attach 3D model. Like it's a little bit strange. But let me just show you how to attach the run line first. NaviPack. When you install NaviPack, you have this structure here. See IVA NaviPack, and you will also see that you have a structure with all the other packages like NaviScan, NaviPlot, NaviPack, NaviModel Produce, and NaviEdit. But under NaviPack, there's something called run lines. There's a selection of run lines here. And the one I want you to use is this one here called AarhusTransit.rlx. And now be careful, because basically I am showing my extensions for known file types. And you can see underneath here, there's one called AarhusTransit.rlx.bak. So if you don't show extension for known file types, then this one will be shown as RLX, but that's just a backup and you can't really use it. So what you have to do, and this is really annoying with Windows, the default is always hide extension for known file types. Go to View, file name extensions. That should be enabled. Once you do that, then you can take this one, Aarhus Transit. It is pretty close to where you are at the moment. Probably not close to where I am. I can zoom out. You can see this is where it is. I zoom out using the wheel of the mouse. And of course, you have the same windows that I have, but I am assuming that you have a dark theme. This is very deliberate on my behalf to have the light theme, because then you guys can see what's going on here. Otherwise, it's difficult to see. You can see this is Denmark. We're right in the middle. This is the approximate location of IVA. Let's just go to ELB26, and then let me repeat once again how you do this. Virtual on-off, right-click, attach 3D model, and then you attach Chuck 3ds down here. So here it is. Now, if I want to sail on the run line, then I must use the simulator here. Use run line. The icon looks like this. As you can see, my cursor at the bottom here. Use run line. And then you must use the same run line that we just loaded. You have to be aware that the simulator and the Helsense display are two different programs. So I loaded it into the Helsense display, and now I need to tell the simulator to use it. Source unit is meters. And now I get warnings. You probably don't get that warning. And I'm getting the warning because I was here and the simulator just made or started creating outputs that came from here. So I was moving 15 kilometers in 1 second. Navipack won't accept that. It is really constantly maintaining an acceptance window or a window of acceptance. And this one was clearly beyond this window of acceptance. If I want to tell Navipack that it's actually okay, the GPS position is okay, then I do it like this. From Navipack Online here, choose Edit Estimated Position. This dialog pops up. And what you are doing now is just saying that use the GPS position. You need to wait a little while. Now it's okay. This is the GPS position. And now we say, okay, so it's basically starting the calculation of course, make good speed, make good filtering, Kalman calculation based on the GPS position rather than on the previous position. So now I am here. You can see that vessel is progressing and sailing on the runway. This is 3D. If you look at these icons up here, you can see 3D. I can also choose 2D, and I'm looking at it from above. I have experienced that people are initially very enthusiastic about using the 3D possibilities, but pretty soon they learn that there are also limitations to it. It's sometimes extremely difficult to see where you actually are in the world. So they go into 2D and only use the 3D possibilities occasionally. But anyway, this is the run line, sailing on the run line. We're going to do that a lot. So you might as well get used to it. Let's also have a look at some other windows that we can see right now. There's this one here called the raw data window, and notice they're all opened from the online window. You can also open this window from view raw data. That's exactly the same thing. This is the raw data window, and by default, it opens the first port defined in our configuration. That is COM2. This is raw data coming in. And down here, you see the interpretation. Latitude, longitude, easting, northing. We have RTK mode, and we have not defined any datum shift yet. There is a string filter. If we choose use string filter, it's only having an impact on what we're seeing here. You can actually see that it doesn't filter anything away because all strings are starting with $GPG. But have a look at it. If I had chosen GTA, then it would only have taken the first one here. If I choose GST and GSA, then I also get some extra information about number of satellites, etc., that Navipack can take into consideration. This is known information. If you know your NMEA format, let me show you again in the documentation side. Coming up. documentation side, related topics. Under related topics, there's something called down here, the NMEA protocol. It simply gives you all these different NMEA protocols that are defined. The GSA is one of them. That's DOP and satellites. Let me see, GSA, GST is not even defined here. It doesn't matter, GST. But GGA, of course, that's the position. So GSA is coming in. So let's have a look at another window. That is the GPS status window. Let me see. There's something called extended view here. Pressing this one here, then I can basically see a lot of things here, like let's have a look at DOP values and all those kind of things. That's all included in the GSA string. If I click on this one, then I can choose what it is that I want to see. These are the hidden headings, and these are the visible. So basically, because I have this string filter, then I get this extra information throughout. We will actually define different settings for the secondary GPS, and then we can have a look at the difference between them, because basically it's the same data that's coming in. As I told you, a simulator is not that intelligent. Well, it's not intelligent at all. We're going to go offline again, so I will enable in the Helsense display the autosave project here. So every 10 minutes is probably a good value like this. So now that's enabled. But I will save it myself before I'm leaving the configuration. Let's go back to our navpack configuration. We will add another instrument to it. Let's write octans again. So this one here, XCRPH BNA format. This is the motion equivalent to the gyro reading from the same instrument, the octans instrument. Click on that one, and then in this particular case, you can have a look. See, I want to use COM4 for this because it's available on the same port. But I can only do that if I enable show used down here. Show used, and then I choose COM4. It was the one that's called BNA format, motion BNA. That was a question from ELB. I'll just repeat it again. Just type in octans as my filter. Then I choose this one here. As I said, this is the motion equivalent to the octans gyro. And again now, it's not available until I choose show used. So now it's available. COM4, same settings as for the gyro. Now, let's have a look at the configurations. Yeah, can start with the offsets. And the values, again, that I'm typing in here are the values that I have chosen for the exercise in the afternoon. 1.1, 2.2, 3.3. And of course, it's for a motion sensor, it's different from a gyro because you're at least the heave part of the motion sensor will be different in different locations on the vessel. Gyro is always the same, roll and pitch are the same, but heave differs. Therefore, it is important to type in your offsets like this. IO mode is simulated. Again, I don't have any C-O's here, but they will again be added to the raw data. Like the octans gyro, we need to specify the latency here. And now, of course, you have to be careful with this one here. You can reverse the heave. And this is something you have to do if your heave is not positive up. And the funny thing, well, I don't even know if it's funny, but peculiar thing with X-Blue is that they have the same format, but in some instruments, and I'm referring to the BNA format, in some instruments, positive is up, in others, it is down. So that's very confusing. You have to find out just by lifting the motion and see, oh, this is positive, then it's fine. Oh, this is negative, and you have to reverse it. This is, of course, a setting that will be inherited in NaviEdit, and you can also change it in NaviEdit if you want to in post-processing. Now we come to the tricky part, and I promised you that I would explain. You can see that the settings for number of bytes, telegram per cycle, driver type is the same for the gyro and for the motion sensor. They have to be the same because of the way that Navipack is constructed. You've seen that we're using the same port for these two, which makes perfect sense because they're coming from the same instrument. So it's coming through the same cable on the same port. The gyro driver is controlling the motion sensor driver as well, because it's the first one on the list. And they're coming from this on the same port. That's important to always check that these are in compliance and then they have the same settings. An example that unfortunately I've seen many times is that in support, that is, people are using, well, they're saying, okay, the octans gyro, it says NMEA HDT, so why don't you should never do this. This is important to emphasize, never do this. I'm just showing you an example of something that you should never do. See, if I change this one down here and say prefix ASCII, and then I type in here $HEHDT, then what happens is that the gyro is fine. It's still working fine, but the motion, no data is coming in. Because Navipack will use these settings and say, okay, what can I use? I can only use those strings that are starting with $HEHDT. If we go to, even though we haven't defined the motion, we can still see it in the raw data file here. See, this is how they look. This is motion on the PHTRH. This is the motion. This is the heading, but it's only using that one, filtering everything else away. And people, and understandably, find it a little bit difficult to understand. But that's because you have a lot of degrees of freedom here. You can do many different things with your Navipack configuration. One thing that you should never do is to change this one here. I don't like to see that one at the bottom, so I'll just delete it and then take this one here. So a normal ASCII string with character return line feed. So that means that it'll basically accept everything. Also, those that are related here. Yeah, this is one of the important things to understand in Navipack. You can combine drivers, but you can only combine drivers that are related, like gyro motion here, originating from an octans. You cannot combine a gyro NMEA with an octans motion. That's not possible. Now, next part of what we're going to talk about is related to redundant information. That is extra information. For instance, if you have two surface navigation instruments, how do we handle that in Navipack? Let's add an instrument. This time we already have a rectangle here, so we can just right click and choose add instrument. And then you see the only instruments that are being listed are surface navigation. This time we'll take this one here, GPS2 NMEA. And according to the exercise notes, this one should be interfaced on COM3. And let's have a look at offsets. Like this. Offsets of a GPS antenna relative to the common reference point, the CRP of the vessel. And by the way, this one is called dairy GPS, like this. IO mode, once again simulated. And I'm not going to change any of these items down here. Not yet. It will come up later on, as we've discussed. Two GPS instruments, two surface navigation instruments. I have now the possibility of stopping and starting, but I could also just restart. And then let's see what happens. Now I have two instruments available, and I can either choose to prioritize them or to combine them. I will combine here. I would probably normally prioritize, but I want to combine them here for the sake of the training, to show you a little bit more about what we can do. Estimated position is fine. And it closes down Navipack Online and opens it again. And here is my Helmsman display with light theme. Let me just show you how you can swap to light theme, by the way. Under settings, options, and the theme here is light. You can toggle between the two. And when you say OK, it's going to look like it was, but the next time it opens, it will be with the revised theme. Navipack Online here. To see what's going on, I will open the position monitor view here. Here we have the position monitor view. You can see that the observations converted into eastings and northings are combined here. And you can also see, we call these lines of position. Basically, the easting coordinate is a, well, north-south going line. And this one is also a north-south going line. This one here, the northern coordinate is an east-west going line. And our position or our correction to these observations are of the same magnitude to the two, but with a different sign. And that basically means that we are taking the observations from the two GPSs and making an average value. And this is also fine if you want to combine, if they are of the same quality, but quite often they are not. Let's start, so first of all, to manually create a prioritization where we say, okay, we think that the primary GPS is better than the secondary GPS. So that must be our first priority. This is something you can do manually. Here, view, edit, sorry. Surface position control. No, that's not how it should be done, sorry. Navigation mode, prioritize positioning. We start by defining that. Prioritize positioning. Nothing happened. Nothing is supposed to happen. When we do it again, you can see that there's a new entry here called change priorities. Now, we've got 4 LOPs, 4 lines of position. And we want to tell Navipack that we have 2 groups. That's basically 2 GPSs. Reference group is the first one. We need to tell Navipack, because Navipack is not that intelligent, how do we separate the two. So you click on or you select the last of the first group, and then you insert a separator, because separator will always be inserted underneath the selection. Like this. And then you should notice what happens in the position monitor when I say OK. See, now I have 2 priorities. And I also have 3 buttons over here. I can use these buttons to toggle between combined, primary, and secondary. But at the moment, you can see here that I have priority 1. This is the position of priority 1. And this is then the position of priority 1 calculated down to the CRP. Because what you see here is actually the GPS antenna position. Down here, I have the GPS 2 position, and notice it's identical to the GPS 1 position. That's because of the lack of intelligence in the simulator. This one is calculated down to CRP, and since we have a different offset, this calculation will be different. And here we have the difference between the two. The difference is the difference between the priority 1 CRP position and the priority 2 CRP position. I can toggle to secondary GPS just by clicking here once in the online window. And then you see that the secondary GPS now has first priority. The beauty of it, of course, is that I can also just press combined, and then I get a combined position calculated down to CRP. I'll go back to priority or primary GPS again, and then you can see that the position you have up here is identical to the position you have in the online window. So this is the current position of the CRP. If we go to combined here, you need to consider a scenario. Yeah, sorry. Kuram, I didn't see your question, but you can do it and navigate it afterwards. Yes, that is true. Imagine a scenario where your priority 1 or the primary GPS is a lot better than your secondary GPS. In our case, our primary GPS is actually an RTK. At least that's what we're pretending. And the secondary GPS is a CNAV, which is also accurate, but not as accurate as an RTK. Let's give that information to Navipack. This is an online setting. You give the information using this one here, edit surface position control. And then you simply tell Navipack, and we're talking about the sigma value here. This is, well, it doesn't have a unit, but it's probably, well, it's up to you to do, but it's a relative value. So if I, for instance, say that my RTK has an accuracy of 5 centimeters, let's make it easy. And the CNAV has an accuracy of 50 centimeters. I know it's more accurate than that, but it's, I type in 50 here, or 5. And I need to do it both for the latitude and longitude, 5. And then secondary GPS, I'll type, let's say 25. Let's not make it too bad. I think that's quite realistic, actually, even though the CNAV say that it's better than that. So now we have 5 here and 25. So that means that the accuracy of the primary is 5 times better than the accuracy of the secondary. But that actually means that it's being weighted 25 times higher. So 1 divided by the standard deviation squared relative. So 1 divided by 25, that's, or 5 squared, that's 1 divided by 25. The other one, 1 divided by 25, that's 1 divided by 625, but the factor between them, of course, is 25. Let's see if we can see that up here reflected. You can see that there is a small correction to the primary, but it's approximately, well, it is actually exactly 25 times lower. That is the correction. So our position now is 25 times closer to the primary GPS than it is to the secondary GPS, because we're weighting relative to the inverse of the square of the standard deviation. That is 1 times sigma standard deviation. This could be a good scenario, a good choice if your RTK is a little bit unstable. Because if it drops, then it will use the secondary GPS immediately. And if it comes back in again, then it will use the primary GPS immediately. We can try to look at what happens when we're doing primary. See that these residuals, they will takes a little while before they settle. I call the errors residuals, but that's because that's what we do in Denmark. Takes a little while. So in this scenario, this configuration type, if priority 1 drops, then I don't have position, as a matter of fact. Then I have to manually swap to priority 2. That could be a little bit inconvenient, of course. Whereas if I go to multi-position, it still remembers my settings, takes 2 seconds to settle. And now you see these, the relative corrections are of the same magnitude they were before. So that could be a possibility. But basically you can say we've got 3 options. We can combine without weighting, we can combine with weighting, or we can prioritize. I want to show you something. I can restart now my Navipack. And this is an automatic start, as you can see. I'm not being prompted for anything here. I'm not being prompted to do any definition of surface navigation instruments or anything like that. It comes up in a combined solution. And if I open my position monitor window, you can see that I'm still having a combined navigation with the weighting that I had before. Let's try to do the same thing with if I reset and restart. And now I'm manually forcing a manual start, as you can see here. Position monitor. Now you can see that the weighting has been reset. So weighting of surface navigation instruments, that is an online setting. That would be reset whenever you perform a manual start. This is something to be aware of very much if you are really using this. Now, let me show you how people are really using this most of the time. I will reset and restart. And then I will enable prioritized. That's the easiest way of doing it. And then it will be configured like this automatically. But you need to know the possibilities, and that's what this was all about. Redundancy, basically, we can do the same with gyro. I will add a gyro instrument now. And this one should be, I'm again referring to the configuration. This should be an Anschutz NMEA. This is the exercise that tells us that. And the Anschutz should be on COM5, like this. No offsets, simulated mode, C-O of 2. I don't have any knowledge about time slice or latency on this instrument here. But the important thing is to use C-O here of 2. See, they're all simulated. They're all curry colored, all instruments. If I restart, it remembers the setting from before, prioritized. But I get a manual start because I have added an instrument to the configuration since I was online the last time. Let's have a look at the simulator. What does it say in terms of gyro? See, 350. But the gyro here, and this is, it says T, that means true heading. Of course, a gyro will always output true heading, or almost always. So basically, because I have this setting here, then the simulator can see it from here. Raw data 350 plus the C-O value of the octans, 351. Let's see this is the Anschutz, also 350. Again, the simulator is giving the same data for same types of instruments. So Navipeg will use the first instrument, basically this one here. This will be the primary instrument or prioritized instrument. And this one here is your backup. So how can I toggle between the two online? Can I do it? Yes, we can. There's something here called edit vehicle control. Edit vehicle control. And then here on the gyro, you can see that we have 2 gyros, and there's a red P on the icon, on top of the icon of the octane. That means that that is prioritized. So if I right click on enshoots or primary, and I can set as primary here. Are you sure? Yes, I am. P, and then look at the gyro, it says 352. So that's basically now the enshoots we're using. Again, if I restart, it says 352, indicating that it's the enshoots. But if I reset and restart, forcing a manual start, then it's going to say 351 up here, like this. So by default, this one has top priority, this one has second priority. And of course, I can change the sequence here. See, if I grab the enshoots and then move it upwards until I have a vertical gray line, then now it's the enshoots that's my top priority. And quite often, actually, when you're offshore, people have more than 2 gyros. They could have 3 or 4, and then it makes good sense to try to organize the sequence just by dragging and dropping here. It is also, there's a setting under project settings here, advanced, project settings, advanced, whereby you can switch gyro and motion. Should NemPeg automatically switch over to the secondary gyro in case of lost primary? Of course, the same applies for the motion. I think that's up to the user or to the company to say whether they want that or not. What you have to be aware of course, is that it doesn't swap back automatically. It swaps automatically to the secondary, but if the primary comes back, it doesn't go back to the primary. It doesn't come back to the primary until the secondary also drops. So that's something you have to be a little bit careful with. But again, the change of sequence is an online setting, and it will always be overruled by your configuration when you're doing a manual start. That is important to remember and important to understand. Now, I want to, well, we can just add a motion sensor and just be aware that this is actually in terms of prioritization, this works in exactly the same way as it does with gyro. For the motion, we will take a TSS. This one here, TSS DMS05. That's just motion. That's why that has been selected. And this is now COM6. And again, offsets. something like this. In simulated mode. And yeah, that's more or less it. There are no more settings for this one here. I need to give you some assistance now so that you can do the exercise. I've already told you that what we are about to configure is a well, first of all, Navipack, of course, Navipack in support of Naviscan that is doing multi-beam data acquisition from an RV. You've also learned that Naviscan doesn't have any USB drivers, so we need to define the RV in Navipack as well. So let's start by creating an RV here, add vehicle. Call it RV. And now Navipack will ask you, do you want to make a vessel or do you want to make a subsurface? It doesn't really make any difference. The only difference lies in the icon that it will use to display the object in the configuration here. So let me create. Now I have an RV, as you can see. And it looks like this down here. By the way, I didn't really show you the 3D visualization. If you go to the window to the left here related to the vessel, and then keep the right mouse button down, you would expect the left mouse, but it's really the right mouse button down. Then you can rotate, you can zoom with the wheel of the mouse. Also change the scale a little bit. And then you can see the location of the instruments. I selected the GPS, and now you see the GPS here. Primary GPS. Secondary is up here. Gyros are at the CRP, which appears to be down here, and motion are here close to each other. But you also see it in this is the 3D view, and here you see it from the top view, and this is side view. This can be quite useful, as a matter of fact. The same applies, of course, for the RV. Here you can see the RV, and it's using the 3D model here, RV.3ds. And you can change it to another one if you want to, but for now, this is fine. To link these together, you need to have a dynamic positioning system, a USBL system in the context of this configuration. The USBL system must be defined on the vessel object. Right click here and choose add instrument.
Excuse me, Lars.
Yeah.
Could you please slow a little? Could you please go a little bit slow, as most of us have one
Yes.
screen?
Yes. Yes. Yes, I understand. You only have one monitor. Was that you, ELP? Or was it Karam?
Actually, it was Arcadius.
Yeah, but I can't see who it is. Sorry. I'm not looking at that. I'm looking at the chat. I have 3 monitors, but that can also be a challenge. You have to keep. I will. Sorry. Um, I'll remove the RV. So basically, check it again. You add an RV by pressing this icon here. I think that's probably where I lost you. In the top left corner here, add vehicle. You type in the name of it and choose subsurface. And then you press create. And then basically you have the RV here and properties over here. For now, we're not going to change the properties, but we will at some later stage. And then I was talking about linking the vessel to the RV. We do that by adding a USBL system, or what it's also called in Navipac's terminology, a dynamic positioning system. Right-click somewhere on the virtual on-off and choose Add Instrument. And now we can either select it by simply finding it on the dynamic positioning, but we can also choose the instrument that we're going to use. It's called HiPAP, like this. Dynamic positioning here, Kongsberg HiPAP/APOS. This is the one that we want to add. Okay. And guys, just don't be shy. Just let me know. It's a good thing that you told me that it was going too fast. Please. It's sometimes a tendency I have. So you just make me aware of it and I'll slow down, I promise. The IO selector for this one has been specified as COM8 on the notes. And then I will use the default settings apart from that. Now, there's a lot of items here that we can modify. The IO mode, for instance, should be simulated. But I would like to wait with this a little while, because one of the exercises that you guys are going to do is USBL calibration. And once we've done that, then many of these things will become evident. But basically, you can say, just to give it to you briefly, that the result of a USBL calibration are the gyro, roll, and pitch at angle. This is basically giving us the orientation of the USBL system in the local core system of the vessel. So these 3 values here, we'll also get a scale out of what we will always use 1, irrespective of the scale that we're getting out of the system. There's a possibility of range tolerance, and that's basically the capability of defining or detecting outliers. So basically, we're talking about outliers relative to the range that we have. If we're 100 meters away or between the transponder and the hydrophone, then if we set a value of 10% here, then it will say, okay, everything that is 10% relative to the previous, if it jumps 10 meters, we won't accept it. That's a possibility. Again, use time in Telegram is related to our synchronization of the time, so we haven't done that yet. Binary HiPAP, yeah, if we have a binary HiPAP, yeah, it's a little bit complicated. Transceiver ID, that's if you're running a dual transceiver Kongsberg system, then you have to specify two receivers, and the ID is specified here. You can also use USBL systems for differential USBL. In that case, just like differential GPS, you place a receiver on a known position. Here we place a transponder on a known position, and then we're using the corrections to the known position to also correct other transponder positions. Same magnitude, same direction. That's not relevant for us here. Then there's something with weighting that I'm not going to talk about here. Not now, at least. And then down here we have string details, same as before. Same as we have seen before. But to link the dynamic positioning system to the RV, we do this reasonably simple thing. If you go and place your cursor above the 0, click, left click, then you can choose RV. That's the only other object we have. As a consequence of this, NaviPack will place a transponder on the RV. Look at this. If I put my cursor on the transponder on the RV, then you can see that the dynamic positioning system is being highlighted, shown with a red background, and vice versa as well. See, like this. This is how you do it. I thought that even though you guys had done the e-learning, that I must tell you how this is done. This is actually an instrument on the RV, and basically we have different transponders. And this one here, in the context of the exercise, is called port. And of course, they always have to have a TP code. Otherwise, the HiPAP system doesn't know where the response comes from. We're not going to enable any of these. Normal mode. And then the offset here is -1. Very simple offsets. And you will see later on that that makes good sense. That we have simple offsets because we're actually going to use this proactively. Yeah. If you look at the RV object, you can also see that there are some things that we can define here. First of all, use Kalman. Must be defined. And what does it really mean? It means that Navipack will calculate an optimum position for the RV based on all available information. And the available information could be, for instance, data from a Doppler log. And we are actually going to include a Doppler log on this configuration. Why is that of interest to you? Well, that comes now. And I just have to say, don't worry too much that you don't understand this, because I'm really trying to help you with the exercise. You get all the time in the world in the afternoon to set this up correctly and to also understand what's going on. You could consult the e-learning modules and see what does this really mean. We can also have questions tomorrow, of course, about it. Use Kalman. Navipack does it automatically. You don't have to worry about anything. But if I now go back to the PowerPoint presentation that you have seen a few times. Let me go back to this one here. We are sending a position from Navipack to Naviscan. You learn that this is necessary because Naviscan doesn't have any drivers for underwater positioning. Navipack will send the position to Naviscan, and that's what we are going to do. We are actually going to make several outputs from Navipack to Naviscan, and each time we're using a specific format. So let's take the RV, right-click, add instrument, and then choose data output. This is a data output. It's called position exp to Naviscan, and please be careful here because there are two positions to Naviscan. There's this one here, shouldn't use that, and there's this one here, position exp to Naviscan. That's the one we want to use because it has more information. That's why we are choosing it. Position exp to Naviscan. Now, this is the first time we are creating an instrument that's actually created in Navipack and output towards an external source. So we're going to use a UDP/IP protocol, local IP address. And if you don't have that, it should be 127.0.0.1. You can always auto fill it out by Navipack by pressing this set local host. The port number has been specified to 5005, like this. Now, and we have got it here. Position exp to Naviscan. But we'll change the name and call it. Now we can, first of all, we can try to say, what is the source? Let's choose Kalman. So this is basically the best possible position of the RV. And right now we don't have anything in support of it other than the actual position here, but you will have that in the afternoon. So we're choosing the source Kalman. You saw that there were other sources. One of them is the CRP. That's just the average position of everything. If we have more transponders, or it could be the port, which is basically the raw position of the port transducer. We'll choose Kalman. IO mode on, and then we will give it a name that's called Kalman to NS. Kalman to Naviscan. Like this. Let me just show you how it looks in here. This is your, this is the exercise. All the instruments have been listed with the characteristics of these instruments that I want you to enter. I can also promise you that we are going to go through this into the smallest of detail, very meticulously. And this is then the main vessel in exactly the same way. So you don't have to worry, but I would like you to really do your best once I hand it over to you shortly. We can save the configuration. And of course, I will also be available on Teams if you have anything. Before we split up, there's one instrument that I would like you to include, and that is the ZDA plus PPS. And you remember that we're using a ZDA PPS instrument if we want to synchronize the computer clock to GPS. Navipack will always use the computer clock for its time tagging. So in order to get the best possible time, we need to synchronize the computer clock to some external source, and I think the best external source would be the GPS time or the GPS clock. An instrument like this could be, I could place it on the RV, it doesn't really matter. Generally speaking, when we're talking about instruments that I could place anywhere, I will always place them on the vessel. So let's do that. Right click, add instrument. Miscellaneous. See, we got 436 drivers left. And the one we're going to use is actually the last of those 436 drivers. Set the A time plus PPS. Pulse per second plus the actual NMEA time telegram. I will use COM1 for this, and notice this time you don't have any options. You can only choose serial, and that of course is because this is your only possibility of having a pulse per second. You cannot have that on a LAN interface or anything LAN-based. So, and then I'm using COM1 for this, and that's basically because Moxa boards, for instance, they don't have pin number 9 activated. And we are using pin number 9 for this PPS. At least by default, we are. So COM1. We're all going to get warnings now because we don't have a COM1. I don't even have a COM1. I have 5, 6, 7, 8, or 6, 7, 8, 9, or something like that. But I want you to see the consequence of doing this. Before we do it, we need to tell Navipack which pin, which is the PPS pin. That's done from here. We only have two possibilities. One is the ring indicator, that's pin number 9. The other one is DSR, that is dataset ready, pin number 6. And if you are in doubt about this, you can have a look again at the documentation side. There's one here called IS232 serial communication. Oh, losing my voice now. See here on a male IS232 DB9, pin number 9 is ring indicator. That's this one here. Pin number 6 is dataset ready. That's this one here. So these are your two options. And we'll just leave it as it is with ring indicator. Now, before we go online, let me just show you how it looks now. Edit, date and time, nothing. It's not really, it's just using time as it is. I will restart. And then I might as well choose everything. And now I get this warning here. Could not find COM1. Of course, Navipack is instructing the Windows operating system to open COM1, but it cannot do that because it doesn't exist. Cannot set timeout or anything like that. So a lot of problems. I'm always telling people that if you get warnings when you go online, then you have to go offline and see what goes wrong. Now, the only thing I want to show you is this one here. Edit date and time is now controlled by ZDA, time plus PPS. Because I have it, then it will be controlled by it. There are different ways of checking that this is working. One is to go again and look at the GPS status that we did a little while ago. Age of data. See, I don't have anything here right now. That's because I haven't told it to use time in Telegram. But otherwise, I would see the age of data. This is basically the difference between the current time, that is the Navipack time tagging, and the time in the Telegram, because that's the latency of the Telegram or the position, age of data. And if that is negative or 2, 3 seconds or even 100 seconds, then this is not working, or the ZDA PPS is not working properly. Another way is to go and check and modify the time, change the time a minute or so, and then see if it jumps back again after half a minute or so. Then it's working. But of course, it is important that it works. It's not just important, it is essential. I want to change ZDA time plus PPS to off. Because otherwise Navipack simply won't work with this. But I'll put it to off now, so I won't get these warnings again. But I will pretend that I actually have a ZDA time plus PPS instrument. As a consequence of this, I can, here on the primary GPS, use time in telegram. Basically means I'm using the time tagging of the GPS position and thereby getting a better position. I'll do the same for the secondary GPS. And as a matter of fact, the Kongsberg also has this possibility, use time in telegram. These are instruments that are time tagged externally. They also have a reasonably large latency, especially the Kongsberg, but also the GPS. So therefore, it really makes good sense to use time in telegram for both. You could say that in some scenarios, if you're doing 2D seismic or something that doesn't require extreme position accuracy, then you can just ignore this these settings here. Torque management is the same, but if you're doing multi-beam survey, it is essential. You have to do it. If we go back to the PowerPoint, we had some long discussions about Navipack and Naviscan on the same computer. And of course, I didn't mention it, but Naviscan does exactly the same thing. It also time tags data upon arrival on the port, and it's using the same source, that is the computer clock for this time tagging. Now, try to imagine if Navipack and Naviscan are executed on the same computer. It's enough that Navipack is handling the synchronization of the computer clock to GPS time. Naviscan will use the computer clock as well. If they're executed on separate computers, the best solution would really be to have a ZDA PPS in Naviscan as well, and then let Naviscan synchronize the computer clock on the Naviscan computer. I know that there are also softwares whereby you can synchronize your computer clocks internally on a local area network, but I personally don't think that's such a good solution. I think the best solution would be to use ZDA plus PPS in both locations. But on one computer, it's important only to synchronize once. Okay, guys. That was it for today, at least for the online part of it, or the virtual training part of it. I need to go and get something to eat, I must admit. And then once I'm finished with that, I will send the exercise notes to you. I will, of course, also myself here configure my Navipack in accordance with the notes and with my expectations to you. And you could say that as a plan B, at least tomorrow, if you don't manage to make this work, if for whatever reason it doesn't work for you, then I will. We have the possibility that I can send you my configuration. Then you can use that as your plan B. But I would really like you, because it's important to set it up the way I have specified or will specify for you in a little while when I send it to you. Okay. At this stage, I normally ask people, is it going too fast? But you've already answered that question. And I know that I promised you to slow down, but then unfortunately, we were in the location where I normally speed up because this is just assistance for you guys. You are slowing down when you are adding these instruments one by one, trying to understand what's going on. And then when you're finished, you could try to go online and see what happens. But let me just hear you anyway. What did you think? Are you able to follow what's going on here?
That's fine by me, yeah, no problem.
Yeah. That was you, Stephen.
Yep.
Anyone else have any comments? Of course, there's you, Konstantin, you're a little bit special because you joined it a little bit later than the rest of us. What do you think?
Repeat, please.
Yeah, what I was saying to you, Konstantin, is that you joined us later than the others because you didn't sign up until reasonably late. And there was some problems with your email address this morning. I apologize for that. But do you think you can manage to configure NaviPack?
Yes, it's okay. I can configure NaviPack.
You just have to follow these instructions here.
Yes, and I can use to EVA learning.
That's good. That sounds good. Otherwise, again, we have this plan B tomorrow. I can send you my configuration. But for now, I will bid you farewell. And even though I'll be having lunch now, I will keep my Teams open, and that means that I will be able to answer any questions. I don't promise that I will answer straight away, but I will be here. I will be aware of you all the time, and you can just ask questions if you have any.
Okay, thank you. Cheers. Have a good lunch.
Cheers. Yes, enjoy your meal for sure. I will. Let me see. I need to stop recording. Yeah, now I've stopped recording.